Greetings panels, I am Mary Patricia Avery M. Arsenas and this is my presentation for Architectural Design 9 for the second defense entitled Orb Cycle, an integrated solid waste management and research facility for the development of the dump site in Quezon City through biomorphic and sustainable architecture. This will be my presentation outline starting with the introduction, going through the details about the project and then the proposed design attributes. Introduction. Philippines has poor management on waste. Dump sites have been a way of disposing garbage and the environmental effects of this in our air, water, and land is contamination and pollution which have already outraged contributing badly on global warming, climate change, and also, if these dump sites are poorly managed, this can cause various diseases and illness that can spread and affect the local residents around the dump sites. Laws and policies. These are the prominent laws and policies that has a big impact on the designing process and will serve as a guide in planning of the solid waste management and research facility. Moving on to the project details, the project is a solid waste management and research facility that will embody multiple types of facilities that can handle massive loads of waste in an organized and sustainable process while giving potential to be developed as a manufacturing site that can process raw materials through the use of the innovative and sustainable facilities that are respectful to the environment. The problem statement is that landfills are temporary solution and not enough means as a way of disposal of waste. The main points are how will my project impact the solid waste management? What businesses can my project offer? The effects of reopening of the dump site to the communities and will it help in reducing environmental, health, and safety risk? Project objectives. To educate communities and support sustainable solid waste disposal research, improvement of Old Payatas dump site and establishing new facilities related to solid waste management, utilization of the technologies from the sustainable facilities, and environmental awareness and responsibility. The project scope limitation of the project is intended for the architectural and health progression of the Philippines as well as for the encouragement and showcasing of the development of architecture towards industrial structures, prioritizing the perimeters of Quezon City in Metro Manila. The client for this project will be National Solid Waste Management Commission, which is a major agency that manages, control, transfer, transports, processes, and disposing solid waste in the country, and the Department of Environmental and Natural Resources, a primary agency that is responsible for conservation, development, and proper use of the country's environment and natural resources. The case studies that are the basis of the project is Shibuya Incineration Plant in Japan that incorporates a new stoker technology that has a clear gas emission regulations. San Pablo City Sanitary Landfill and Materials Recovery Facility that has a in-vessel facility that processes the toxic fluids from garbage and turns it into organic fertilizer. And lastly, Legazpi City Composting Facility that has Japan's Okada technology that turns biodegradable waste to organic fertilizer. Next is the macro-meso site analysis. The site is situated inside the perimeters of the National Capital Region, also known as Metro Manila, particularly in Quezon City in the barangay of Payatas, located in the 2nd District of Quezon City. The municipal of Quezon City is the largest city in Metro Manila with a population of 2,960,048. The site is specifically in the 2nd District, which is Payatas, with nearby barangays of Commonwealth, Batasan Hills, and Bagong Silangan. The proposed site is located at the Payatas dump site, specifically the Old Payatas dump site, the upper area indicated on the illustration. Going to the site criteria discussing the site analysis, the topography of the site is relatively flat and has sloping around the previous landfill areas. The geological state of the site has a potential of giving much nutrition on the vegetation and the landscape of the project. The site isn't prone to any seismic and flooding hazards. The land use and the zoning of the site is industrial according to the CLUP of Quezon City and is very ideal for the project as the site is previously a garbage dump site. There is a lot of room for future expansion as the site has a total land area of 22 hectares and is located in a progressive urban area. The site is facing a major road of Visayas in the north with Zamboanga and Clemente as secondary streets on its sides. The site also have existing utility links to Meralco and Manila Water. The SWOT analysis. In the strengths, the site has flat areas, it is along roads, it has availability of land for future expansion, and according to the liquefaction and seismic hazard maps of QC, the site has low flood or tsunamis, seismic activity, and landslide susceptibility. The opportunity that can be done in the site is improvement of air quality, development of business, facilities that incorporates new technology, and improvement of garbage cycle. The weaknesses and threats contains poor site management, garbage issues, and uneven municipal development that the design can work with. In the demand analysis, we have the projected population with a growth rate of 1.92% and the waste collected in Quezon City from 2016 to August 2021, including COVID-related waste. According to the solid waste management profile of Quezon City from DENR, Quezon City has a total of 2.9 million population with 2,645,001 kg per day of waste generation with 940,496,677 kilograms of waste per year and a waste generated capita of 0.88 kilogram a day. In this slide, it contains the formula that was used to determine the waste generation, land area requirement, and the total land area requirement for the project. We will now go over to the development controls, bubble diagrams, and space adjacency matrix. Design constraints, environmental and health constraints. The site will experience super typhoons and the facility itself is a high-risk, toxic, and danger zone. It is a huge challenge to create a design that is resilient to such hazard, but any harmful displays will be restricted from the design that might compromise the health of the workers, the surrounding communities, as well as the environment in the site. Social constraint. The primary users are LGUs within the Quezon City. The project must be socially acceptable in terms of design, planning, and concept where it will not create a bad impression or harmful impact to the health of its users. Structural constraint. This prototype design for the structure will be built with the same features as any normal office, residential, and commercial project with safety and protection of the primary workers and the community is highly considered given that they are high risk on being around the site or working in the proposed project. Going to the proposed design, the architectural approach for the project is biomorphic architecture, not only because of its shape and forms that are inspired from nature, but also its purpose of making the design of the project connected to nature that can contribute to the well-being of the occupants as well as the surrounding community. Next is the form concept, a beehive that has different sectors made from array of materials in the place where the bees are in. Applying it to the project, the structural form concept of a beehive or the chronological order of the space needed for the bee colony is to be applied in the proposed project as it gives a benefit of space efficiency. What you see in this slide are the design considerations. First, safety for fire exit, safety alarms that will be provided for emergency purposes and air filtration system and disinfection base as a health precaution. The site will be provided with CCTV as a form of security to avoid users from any type of threat inside and outside of the property. Sanitation for providing proper sanitation base and cleaning amenities while handling hazardous waste. Comfort for proper ventilations inside the building to meet the user's satisfaction. Circulation for proper flow of people and vehicular traffic inside the site, and it is very important to be considered as this is a solid waste management facility. Accessibility, everything within the project regardless of disability or special needs of the users can access, use, and benefit from the proposal. Audibility, trees and soundproofing building systems are provided to reduce noise coming from the processing machines. Knowledge to gain more information through the informative research lab displays. And lastly, aesthetics, considering the beauty and the features applicable for the project. Next is the structural concept, which is timber and steel. The natural entities of the site may be maximized and preserved throughout the construction phase. Also, this type of construction gives an emphasis on the built relationship between the structure and the environment of the site. The material concept of the project has three main materials for the entirety of the buildings, namely wood, steel, and laminated windows. Wood and steel, when combined, provides an ambience to the occupants that connects and associates them to the natural environment around them. Also, wood has a lighter carbon footprint than other commonly used building materials, while steel has recycled content and will contribute highly to the structure's stability. And lastly, the laminated glass has a robust structure and shatterproof ability that can be added safety and security, insulation, and solar energy control. The special allied services that are considered for this proposal to enhance and be beneficial to the composition of the buildings of the project are the Solid Waste Management Commission, the Local Government Unit, Urban Localities, Acoustic Design Services, Facilities Maintenance, and Special Facility Planning and Design. The innovation and highlights to be applied in the proposal are sustainable building features and disinfection or decontamination base. Disinfection or decontamination base is an innovation with a goal for the primary users of the project to be safe from getting or spreading diseases to the community, so that when they are handling, processing, or disposing the garbage, it will be an effective way of providing safety and health security that is safe for the environment and to the users of the project. Here are the prominent sustainable building features to be applied in the project. First is energy efficiency. Limiting the heat energy loss through the day-to-day operation of a building will reduce greenhouse gases emissions through utilized building envelopes like double facade or exterior shell, high-quality windows and wall insulation for air leakage, and heat recovery ventilator to capture heat energy and lighten the load on the mechanical system. Second is renewable energy generation using a good building envelope that is supplemented with energy-efficient mechanical system with renewable energy generation, like producing electricity. It will reduce greenhouse gases emission by circulation of energy. The third and fourth building features works hand in hand, as water efficiency and stormwater management are about water conservation by taking advantage of alternative water sources like rainwater or grey water that can conserve water supply through planting of greenery and green roofing systems. The water collected can be repurposed to flush toilets, cleaning, garden, and the plants will help with the flood control. And lastly, indoor environment. To improve the health and well-being of its occupants, features that improve the indoor environment will include ample amounts of daylight, good acoustic performance, high-quality views, and excellent indoor air quality. That concludes all of the contents of my presentation. Thank you for listening.